Okay, welcome back. We're talking about how to pick primary keys. So it's fairly obvious I can't pick semester as the primary key because there's duplicates. And let's see if there's any duplicates here. Oh yeah, plenty of duplicates. Duplicates here, yes. Duplicates here, yes. I mean, geez, is this one of the ones where you just throw your hands up in the air and say, oh, to heck with it, I'll come up with a synthetic surrogate auto number? Or could we figure out that there's a couple of these columns that when combined together do make a compound key? That's what we're going to be doing a little bit later on. Okay. So the next concept we're going to be talking about on page 158 is this thing called functional dependencies. And functional dependencies is not really that difficult to get your head around. What it basically means is, given a student ID, I should be able to tell information. Okay, so given a student, I'm going to go back to this guy. Given a student ID, I should be able to tell their first name, their last name, their primary major, their student type, and their phone. That's a reasonable assumption. Just think about it in your head. I mean, if I said, given a student ID, I shouldn't be able to tell, I should not be able to tell which professor is teaching a course. That had anything to do with the student. Okay? Or which courses are being offered that semester. That had anything to do with the student. So it's about a student and then the things that you could normally expect to know about a student. Okay, that's what that means. So given an account number, I should be able to tell the name and address of a person. Given the quantity and the unit price, I should be able to do some math and figure out what the extended price is. In other words, you order 3 things and they were $1 a piece. I should be able to figure out that the extended price is going to be $3. Okay. So the practical application of functional dependency, what does it do for me? Well, it's a technique that's used to verify that a table is done correctly. Or conversely, if a table is not done correctly, you can use functional dependency as a tool or a technique or a method of breaking the table up into smaller pieces until it does meet the definitions. Okay, that's what it's all about. Okay, the examples on page 159 are really pretty bad because their examples of functional dependencies are things like, quantity is 3 and unit price is 3, therefore the extended price is 9. Like you're doing math or something. That's not at all what we're talking about here. Functional dependency is more about, given a primary key, what can I reasonably expect to have attached to that primary key? Okay, so the determinant. The determinant is the thing. Like in this case, the determinant would be the student ID. The student ID is the determinant that determines the first name, last name, blah, 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 blah. You could have a compound determinant because a determinant is a primary key. You could have a compound determinant. Okay, good. And so they make up this little notation. And I'm not really keen on the notation, but let me just go ahead and here's how, if you were to talk about this, you could say, for example, that account number, and then they do this little thing, determines, I don't know, first name, last name. Okay, and I'm not sure how useful this notation is, but it is in the book. It's just called the functional dependency notation. Okay, and by the way, don't get this confused because later on we're going to be talking about text-based relational notation. That is not the same thing. Don't get this confused. Okay, so let me ask you, let's go back to this question about determinants. So are all determinants unique? Yeah. In order for this to work, every determinant has to be unique. This is an example of one that doesn't work, but just bear with me. For a student ID should always be unique. Okay, that's how it works. There is using their example. Okay, their examples are, I don't like their examples for this reason, but they could have, they could say, for example, the determinant would be something like unit price and quantity determine the extended price. Okay, now in that scenario, well then no, the determinant doesn't have to be unique. Okay, But again, I don't like their examples on whatever, page 159. So I'm just going to move on. Okay, so let's go in here and talk about functional dependency. So here's an example of where functional dependencies. So I have an item number, okay, and the item determines, is it reasonable? If I gave you a stock number of 2, would it be reasonable for you to know that we're talking about a sweater, and we're talking about its size, and we're talking about the color? Okay, that's kind of I'm thinking, yeah, if you give me a stock number, I should be able to tell that this is a blue sweater in medium size. Yeah, I'm thinking you should be able to do that. Okay, that's kind of sort of an example. Okay, so let's just stop for just a second and talk about functional dependencies one more time, just to make sure this kind of sinks in. So, are functional dependencies good? Bad? Well, I mean, are we trying to get some functional dependencies or remove functional dependencies? What are we trying to do with these guys? Well, the answer is it's a tool. And when you're done, you're probably going to have one functional dependency per table. Okay? So yes, the goal is to have one functional dependency per table. So if you ended up having 2 on a table, well, then you probably need to split the table. Okay? So remember that first rule of a relation? The very first rule of a relation was everything in the table has to be related to one entity, like student. Don't throw in professor in a student table, because professor would be in a professor table. Okay? All right, good. All right. Let's go back to keys on page 163. Hopefully we've talked about this enough, but let's just go through it one more time. So a key is nothing more than a column, right? Don't get excited here. A column that can be uniquely identified would be a primary key. Okay, good. A compound or composite key is where a single column can't do it. So for example, I happen to know that it'll take 3 columns. It'll take this column, and that column in order to make this thing unique. Okay, we are going to come back to that. So a compound or composite key, good. So what's a practical distinction between a candidate key and a primary key? A candidate key is one of the ones that could be used, but we just chose not to. That's all. It's not any worse or better. You know, if you had a student ID and a student email, I could use either one of them to uniquely identify the row. So one of them is a primary and the other is a candidate, or vice versa. It doesn't matter, right? It's just which one you pick. Okay. So one more time, talking about relational notation. I'm not talking about functional dependency notation. I'm talking about the real text-based relational notation, where you have something like student, and then you put in like student ID, and then, first name, et cetera, et cetera, et cetera. And then this is underlined. I'm in Notepad here, so I can't really do underline very well. Okay, so you guys remember this, right? Good. So this is text-based relational notation, or sometimes called schema notation, where the primary key is underlined. That means you always tell which one it is. Okay, I'm going to go back to this example with the primary keys. So let's just say you said, well, I'm going to pick the semester as a primary key. I'm going to zoom out a little bit. It's going to be a little harder to see, but that's okay. You've already seen it once, so I think you're all right. If you picked just the semester, well, then that would yield like 4 different rows. That can't happen, right? If I pick just one course, well, then that would pick like 3 rows. If I pick the section, that would be 6 rows. If I combine the column A and B together, well, I get 3 rows. If A and D, I get 2 rows. And you just keep going and going and going until finally you figured out that the semester and the course and the section is what it's going to take. And you just have to noodle this thing through. Just kind of look at it and go through. Now, sometimes if your table is really, really huge, you're not going to be able to look at it and tell. Okay, so I'm going to show you an alternate technique that is probably a little better off. So I've got SQL Server up and running here. So I'm going to go here and click on this thing called Chapter 3. And it's just going to load this script for me. And I'm going to execute. Okay. So now I have a new database in here called Chapter 3. And so I'm just going to show it to you. If you guys remember how this worked from the previous time, if you go in here and grab this schedule table, and I could say select top 1,000 rows. So here they all are. All right, cool. So what I'm going to do is I'm going to go in and I'm going to start designating keys as primary key. So I'm going to go here. I'm going to go to this. I'm going to design. And I say, I want the first one to be the primary key. Great. So I do a right click and say set primary key, and I hit save. And it comes up and says, man, we can't do that. We've got duplicates. I go, oh, okay. Great. I'll hold the key down. I'll light up 2 of these guys and set the primary key. And I'll hit save. Oh, man. That still don't work? Okay. Let's try the professor ID. Let's see if that'll work. No, it ain't going to work. Okay, let's get rid of the I need to undo that. Let's do this one, and this one. Set primary key, hit save, and voila, it likes it. Mikey likes it. So sometimes you can't actually see all the data, right? If you had 1,000 rows in there, you're not going to be able to look at the data and go, well, I see which columns we're going to use. Sometimes you just have to duke it out, okay? So this is a good example of not having to, don't even have to look at the data. You can just start pecking around at it saying, okay, it looks like this is going to be my compound primary key for a typical schedule, a multi-year schedule. Let's go look at this example one more time. So what this is a way to represent multiple schedules each semester. So each semester, there's a course that's being offered, and it's being taught by some professor number 12, whoever that is. And then in the summer semester, and then the fall semester, blah, 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 blah. Okay? So this is like multiple, when you go to the university website, you get to see the current semester schedule. Well, this is like the last 3 semester schedules all crammed together in a single table. Okay? Cool. All right. I'm ready to move on. Good. Okay. So one more time, another way of solving this would be to go in there and say, screw it, I need another way of doing it. And the university does this, believe it or not, because quite frankly, having 3 keys as a compound key is kind of nasty. So they make up a number. They call it the course reference number. And so they can have 1 key to uniquely identify a row rather than 3, because 3 would be kind of painful. Okay, most likely it's going to be an auto number when you do this, so it's not like, you have to go in and tell it what the number is. It just automatically numbers it for you. Okay, in 166, they talk about the foreign key again. So sometimes you add a key to a table in order to be able to connect it back to another table, or most likely you don't have to add a key. Most likely the key's already there. You just need to designate it as being a foreign key. So one of the questions that comes up is, if I have 2 tables, how do I determine which table the key goes to? Now, to tell you the honest to God truth, we're going to talk an awful lot about this in Chapter 5. So I'm going to give you a very simple rule that's going to make sense for the short term. And the short term is, if there is a one-to-many relationship, okay, a student can take many courses, okay, one-to-many. When there's a one-to-many kind of relationship, the foreign key always goes on the many side, okay? That's just a simple rule. And again, we're going to reinforce this an awful lot. There's a lot more rules than that, but just saying. In a one-to-many relationship, the foreign key is almost always going to be on the many side. Okay, in relational notation, the foreign key is going to be in italics, and I can't do that in here. Maybe I should have done this in WorkPad. Doggone it. Okay, we're coming up on the 15-minute mark, so you guys know how this works.